Good morning, children. Today we are going to revise the laboratory preparation of carbon dioxide and the poisonous nature of carbon monoxide. Both are in our long answer questions from the chapter 9, carbon. Let us start with the laboratory preparation of carbon dioxide. This is the setup for the preparation of carbon dioxide in the laboratory. For the preparation of carbon dioxide, we need a round-bottomed flask where we are taking the reagents. There is a thistle funnel, a delivery tube, and there is a collecting jar where we are collecting the gas. The round-bottomed flask, it is fitted with a cork having two holes. One of the hole is fitted with a thistle funnel and the other one is fitted with a delivery tube. Before closing the round bottom flask, we are taking marble chips. Marble chips are actually calcium carbonate. Chemically, marble chips are calcium carbonate. So one of the reagent here is calcium carbonate that is taken in the round bottom flask. After closing this or after set up all these things, we closed and here we have the thistle funnel. Through this, we are pouring dilute hydrochloric acid. This is the second reagent for preparing the carbon dioxide. The first one was calcium carbonate and now dilute HCl is pouring through the thistle funnel. Whenever dilute HCl come in contact with the calcium carbonate, it will react with the calcium carbonate and forms calcium chloride and carbon dioxide. Here carbon dioxide is a gas, so it will go through this delivery tube and we can collect it here in this collection jar. And the method of collecting here is upward displacement of air because carbon dioxide is more denser than air or it is more heavier than air, so that we can use upward displacement of air method for collecting carbon dioxide. Now let us move to the carbon monoxide. Carbon monoxide, it consists of one carbon atom and one oxygen atom. It is a colorless, odorless and tasteless flammable gas. It can catch fire. But it is used for many industrial uses. Being a poisonous gas, it pollutes air. Carbon monoxide is a pollutant, gaseous pollutant. The concentration of carbon monoxide we can measure in parts per million. Usually, the substances with a low concentration are expressed in parts per million. In short, we can call it as ppm, parts per million. This tells us the number of parts of substances present in 1 million. In 1 million of the substance we are taking, in that how much parts of the that particular substance is present, that is parts per million. The concentration of carbon monoxide in air is also in a low amount, so we can express this also in parts per million. For example, a carbon monoxide level of 100 ppm in a city indicates that 100 liters of carbon monoxide is present in 1 million liters of air in that city. Here we can see 1 million liters of air we are taking. In that, how many parts of carbon monoxide is present? 100 liters of carbon monoxide. So parts per million means the parts present in 1 million. Next we have the poisonous nature of carbon monoxide. First of all, you must know the transportation of oxygen in our body. How the oxygen is carried to all of our body parts. Say this. This is the cycle of oxygen transportation. When we inhale the air, it goes to the lungs where the gas exchange is taking place. From the lungs, blood takes oxygen and then it transports it to the other body parts. In the blood, we know that there is red blood cells, and in this red blood cells, we have hemoglobin also. Actually, hemoglobin is combining with the oxygen from lungs, and hemoglobin is the carrier of oxygen. When hemoglobin combines with oxygen, it forms oxyhemoglobin, and this oxyhemoglobin will go whenever the blood is moving or when it goes to the other parts of the body. This oxyhemoglobin is also moving, and the oxygen will go to the cells and tissues in our body. In the cells and in the tissues, respiration will take place, and that during the respiration, oxygen will used up and releases carbon dioxide. So this carbon dioxide again carried by the blood and come to the lungs. From there we are exhaling carbon dioxide. This is the oxygen cycle, or this is how the transportation of oxygen takes place in our body. Now let us see, what if we are inhaling carbon monoxide in a large amount than oxygen? What will happen in our body? We already said that hemoglobin carries oxygen and carbon dioxide. Oxygen to the parts of our body or to the tissues, and from the carbon dioxide again carried back to the lungs by hemoglobin. So hemoglobin has a combining capacity with the oxygen. But if carbon monoxide is coming, then hemoglobin will combine carbon monoxide easily than oxygen. The combining capacity of carbon monoxide with hemoglobin is very high than that of the oxygen. So instead of oxygen, carbon monoxide will combine with the hemoglobin, and then carbon monoxide will carry to the different parts of our body. This is actually happening when we inhale carbon monoxide in large amount. The affinity means like. The affinity of carbon monoxide for hemoglobin is 325 times greater than that of oxygen. That means carbon monoxide can easily combine with the hemoglobin than oxygen. If carbon monoxide and oxygen is present, then hemoglobin combined with the carbon monoxide. So the formation of carboxyhemoglobin will take place, and it will cut off oxygen supply to the cells, and adverse effects are seen. You know that our cells need oxygen for the respiration and for the energy preparation. The severity of the symptoms depends on the amount of carbon monoxide in the blood, how much carbon monoxide we have inhaled, or how much carbon monoxide carried to our body parts. According to this amount, the symptoms and the severity will be increasing. A person may die of asphyxia in an environment of carbon monoxide. If you inhale a large amount of carbon monoxide, a person can die also due to the lack of oxygen, or we can say it as asphyxia. So no one should not sleep in a closed room heated by a coal fire. When coal fire is there in a closed room, there is no enough oxygen, or the oxygen in the room used up for burning the woods or burning the coal. So the amount of oxygen will be less in the room, and also carbon monoxide will come out from the coal fire and we will inhale it. So never sleep in a closed room containing a coal fire. Effects of carbon monoxide poisoning. See, it is depending upon the amount of carbon monoxide. If 100 parts per million of carbon monoxide present in our body, blood, then it causes headache and disorientation. If it is 300 parts per million, it may cause loss of consciousness. We will be unconscious. And what if it is increased up to 600 parts per million? Then it will cause coma. And if again it increased by 800 parts per million or more, then sure it will cause death. So carbon monoxide is a poisonous gas and it may cause death also. So what if a person affected by carbon monoxide poisoning? The first thing we can do is the person should be exposed to an excess of oxygen. You know about the oxygen mask and all. So we have to give more amount of oxygen to that person. A person suffering from carbon monoxide poisoning should be kept on oxygen till she or he recovers. Next we have industrial uses of carbon monoxide. It is used as a reducing agent in metallurgy. Carbon monoxide has a great affinity towards oxygen also, so that it can easily accept or it can easily take oxygen. So we can consider it as a reducing agent, and in the metallurgical process to remove oxygen from the minerals of metals, we are using carbon monoxide. It removes oxygen from the metal and sets the metal free. This is the reaction. Metallic oxide, M here stands for metal. Metallic oxide, when combines with the carbon monoxide and on heating, it takes carbon monoxide takes the oxygen with it and then leaves metal only and forms carbon dioxide also. That is the general equation. Now we have iron oxide. Iron oxide is a mineral of iron. When combines with the carbon monoxide, it forms iron and carbon dioxide. So we get pure iron by treating iron oxide with carbon monoxide. Here carbon monoxide acts as a reducing agent. And the reaction, it is with ferric oxide. First one is ferrous oxide, second one is ferric oxide. Here also oxygen can be taken up by carbon monoxide and forms carbon dioxide. It is also used in the metallurgy for the refining of nickel. To remove the impurities from the nickel, we are using carbon monoxide. It can be used in the preparation of organic compounds such as methanol, hydrocarbons, acetic acid, phosgene, etc. So this is all about carbon dioxide and carbon monoxide. Both are in the long answer questions. Preparation of carbon dioxide and also the poisonous nature of carbon monoxide. Hope you understood. Thank you.